Hello everyone, I am Devanshu Mukherjee and I am excited to present my internship project on a hotel booking platform built using the MERN stack. Over the last few weeks, I have learned how to design, develop, and deploy a full stack web application from scratch. In this session, I will be sharing my journey, the system architecture, key features, implementation details. During my internship, I worked as a full stack developer intern where my primary task was to build a complete hotel booking platform using one stack. I worked across both front-end and back-end, which helped me understand all layers of the modern web application. I gained hands-on experience with tools such as VS Code, GitHub, and MongoDB Atlas. Throughout the internship, I followed a structured development process, including requirement analysis, UI design, back-end API development, database modeling, testing, and documentation. This internship not only strengthened my technical skills but also helped me understand how real world web applications are built and deployed. For my internship, I set a few clear goals to guide my learning and development. The first goal was to understand how real world full stack development works, especially using the one stack. I wanted to get hands on experience in both front end and back end development. Another major goal was to build a complete hotel booking platform from scratch, including UI design, API creation, database modeling, and core booking functionality. I also aimed to improve my debugging, testing, and deployment skills. Finally, I focused on learning industry standard tools like Git and MongoDB Atlas and developing clean, maintainable, and well documented code. Overall, these goals helped me stay focused and ensure that I made the most out of my internship. My internship project was to build a complete hotel booking platform using the MERN stack. The platform provided users with a simple and intuitive interface to search for hotels, explore room details, check availability, and instantly book rooms. For the backend, I created APIs for authentication, hotel listings, room management, and booking operations. On the front end, I designed a responsive interface for both users and administrators. The platform also includes an admin dashboard where admins can add new hotels, upload images, manage rooms, and oversee bookings. Overall, the project simulates a real world hotel booking system and helped me understand the end to end development workflow from gathering requirements and designing the architecture to building, testing, and deploying the application. My project includes a variety of features designed to make hotel booking simple and intuitive. Users can register and log in securely using JWT authentication. Once logged in, they can browse through hotel listings, view details, check room availability, and make bookings instantly. The system also includes search and filter options such as location, price range, and room type to make it easier for users to find the right hotel. In addition to the user features, I built an admin panel where admins can add new hotels, upload images, create room types, update details, and manage all bookings. The platform is fully responsive, ensuring a smooth experience on both mobile and desktop devices. Overall, these features bring together a complete hotel booking workflow similar to modern travel and booking websites. The architecture is a high level architecture of the hotel booking platform. On the client side, we have the React single page application, which handles routing, UI components, and makes HTTP requests to our backend using Axios. The backend is built with Node and Express and exposes RESTful APIs for authentication, hotel and room management, and bookings. Authentication uses JWTs, protected routes, verify the token before allowing sensitive operations like booking or admin tasks. All persistent data is stored in MongoDB Atlas with separate collections for users, hotels, rooms, and bookings. The booking engine in the backend is responsible for checking room availability, calculating total cost, and saving bookings automatically. to avoid conflicts. Optional integrations include image hosting using Cloudinary or S3 for hotel photos and a payment gateway like Stripe or Razorpay if payment functionality is included. For deployment, the front end is hosted on Vercel, Netlify, and the backend on Render, Heroku, or an AWS instance, while the database remains on MongoDB Atlas. This setup provides a scalable, secure, and maintainable architecture suitable for production. For the database, I chose MongoDB because the application needs flexible schemas for hotel metadata and room types. I divided data into collections, users, hotels, rooms, and bookings. Relationships are modeled with object ID references. For example, each room stores a hotel ID, and each booking stores user ID, hotel ID, and room ID. To make the booking process auditable and resilient to future price changes, I denormalized a price into the booking document at creation time. For common queries, I added indexes like a unique index on users.email, an index on a hotels.city for search, and on booking.room ID and date fields to speed availability checks. Because booking involves multiple collections, like checking availability, saving the booking, and updating availability or holds, I use MongoDB transactions in the backend to ensure atomicity and avoid race conditions. Finally, I keep optional collections like reviews and payments separate so they can scale independently. This design balances query performance, flexibility, and data integrity for a production-ready hotel booking platform. The MERN stack stands for MongoDB, Express, React, and Node. I used MongoDB as a flexible document store to manage hotels, rooms, users, and bookings. Express and Node from the backend. Express provided a fast routing layer and middleware for authentication and business logic, while Node handled the runtime and the input and output. On the front end, React made it easy to build a responsive single-page application with reusable components for hotel cards, booking platforms, and admin dashboard. I chose MERN. It's a full JavaScript stack, which means JSON flows naturally from front end to back end to database, which speeds up development and reduces context switching. For a booking app that needs flexible schemas, quick iteration, and reactive UI, MERN is a great and very good perfect fit. For the front-end implementation, I use React with functional components and hooks. The app is a single-page application powered by React Router for navigation. Main routes include home search, hotel details, booking, user dashboard, and admin dashboard. I structured the UI as a reusable components such as hotel card, hotel list, hotel details, room card, and booking form. These components make it easy to maintain and reuse UI elements across the app. State is managed with local component state and the context API for cross-cutting state like authentication and current booking. For larger apps, I would use Redux, but context met the needs for the internship project. All API cells are done using XCS. I implemented loading states and error handling. Users see spinners while data loads and meaningful messages when actions fail. Forms are built using React Hook form with client-side validation for booking dates and required fields. For styling, I use Tailwind CSS to keep the UI responsive and mobile first. Images uploaded to Cloudinary or stored locally during development and displayed via an image carousel on hotel details page. Finally, I added basic component tests using React testing library and prepared a production build which can be deployed to Vercel or Netlify. This front-end design emphasizes reusability, responsive UI UX, and smooth interaction with the backend booking APIs. For the backend, I use Node.js with Express to build a set of RESTful APIs. Mongoose acted as the ODM layer connecting to the MongoDB atlas. Authentication is handled using JWTs. On login, the server issues the token, which the client sends in the authorization header for protected routes. Core routes include hotel and room code endpoints, search endpoints, and booking endpoints. The booking flow requires careful handling. The server checks for overlapping bookings for a room and then creates a booking only if enough rooms remain available. To avoid risk conditions, I perform the check and booking inside a MongoDB transaction session so that the operations are atomic. I used middleware for authentication and centralized error handling. For validation, I employed Express Validator, validate incoming request. For testing and debugging, I relied on Postman and automated tests using Supertest for key endpoints. For logging, I used Morgan Winston and kept sensitive values and environment variables. Finally, the API was prepared for deployment with calls handling, rate limiting if needed, and configuration to run on platforms like Render while connecting to MongoDB Atlas. The booking logic is the heart of any hotel platform. The flow I implemented starts with validating user input, checking dates, guest count, and room selection. Next, the backend checks availability by finding existing bookings for the requested room that overlap with requested dates. The overlap condition I used is an existing booking overlaps if its check-in is before the requested checkout and its checkout is after the requested check-in. If available, the system calculates the total price, nightly rate into number of nights plus taxes or fees, and then creates the booking inside a MongoDB transaction to ensure atomicity. For payment-enabled flows, I first create a temporary hold and only finalize the booking after successful payment. If payment fails, I roll back the transaction. To prevent race conditions, when many users try to book the same room simultaneously and rely on transactions, for extremely high contention, we add optimistic booking for a secondary lock mechanism. Finally, I didn't denormalize key room details like price, room type into the booking document so historical bookings remain accurate even if room prices change later. The admin panel is the control center for hotel owners and platform administrators. It allows admins to add, update, and remove hotel listings and room types. For each hotel, we can upload multiple images, add amenities, and set location and pricing details. Rooms can be created with the total number available and price per night. Admins can view and manage all bookings. They can filter bookings by date, status, hotel, or user, and perform actions like confirm, cancel, or process refunds if payment integration is enabled. There's also a simple user management section to view user accounts and change roles or deactivate suspicious accounts. Security is important. Admin routes are protected with a role checking middleware on the backend and a UI gating on the front end. All destructive actions show confirmation models and log entries are stored, created by updated at. So we have an audit trail. Final, the admin dashboard displays KPIs, total bookings, occupancy rate, and revenue, giving admins a quick view of platform health. Like any real world project, I ran into a number of challenges during development. One of the biggest technical risks was concurrency, ensuring two users can't book the same room at the same time. I addressed this by using MongoDB transactions and careful overlap check logic, and by adding short-lived holds during the payment flows. Date handling and time zones were another tricky area. I standardized on UTC storage and normalized dates to hotel local time zone when displayed and clearly documented with a click-in, checkout as inclusive or exclusive. Security was a priority. I implemented JWT authentication, rule-based middleware for admin operations, input validation, and security headers. For media, I offloaded image storage to Cloudinary and used lazy loading to improve performance. I also faced deployment issues like cores and environment configurations, creating a staging environment and using environment-specific configs, which helped avoid production surprises. To handle performance, I added relevant database indexes, paginated APIs, and lazy loaded images. Finally, balancing scope with deadline was a challenge. I prioritized an MVP, created a backlog of enhancements, and iterated based on feedback. These changes taught me a lot about building robust, production-ready systems. During this internship, I gained a strong understanding of a full stack development using the MERN stack. I learned how to build structured REST APIs, manage authentication using JWTs, and set up secure role-based access for users and admins. I also deepened my knowledge of database design, especially how to model relationships using users, hotels, rooms, and bookings. Implementing real-world booking logic taught me to handle date overlaps, transactions, and concurrencies. Another key learning was debugging, using tools like Postman, browser dev tools, and logs to identify issues quickly. I also learned how to deploy both front-end and back-end, manage environment variables, and resolve course issues during the uptime. Overall, the project helped me improve my coding practices, write cleaner components and APIs, and understand the complete journey from development to deployment. In conclusion, this internship has been a very valuable experience for me. I was able to build a complete full stack hotel booking platform using the MERN stack, covering everything from the user interface to backend APIs, database management, authentication, and deployment. Throughout the project, I learned how to structure a real-world application, handle challenges like booking logic and security, and deliver a working product from start to finish. I also improved my coding practices, debugging skills, and understanding of full stack architecture. Overall, this internship helped me grow both technically and professionally, and it has given me the confidence to take on more complex full stack development projects in future. Thank you. For the future scope of this project, there are several enhancements that can make the platform more powerful and user-friendly. One major improvement would be integrating online payments using Razorpay or Stripe, which allow users to complete bookings securely within the application. I also plan to add a reviews section and rating system so users can share their experiences as well as a wishlist feature to save hotels for future bookings. Notification features like email or SMS confirmations would further improve the user experience. On the search side, advanced filters like amenities, price range, and map-based hotel search would be added for easier discovery. The platform can also be expanded into a mobile application for better accessibility. For admins, role-based management and detailed analytics dashboards can help track revenue, occupancy, and hotel performance. Finally, integrating AI-based recommendation systems can personalize hotel suggestions based on user behavior. These improvements would take the platform to the next level, making it more complete and production ready. Finally, coming to the end of the presentation, I would like to express my sincere gratitude to all the teachers for their constant support and guidance toward the internship. Thank you for giving me the opportunity to learn, explore new technologies, and gain real world experience through this project. This internship has helped me grow both personally and professionally, and I truly appreciate the encouragement and trust you have shown in me. Thank you once again for helping me out. I would love to meet you again in the future.